In Lesson 3.1, Day 1, Examples 1 through 3, you are going to be identifying linear equations and writing them in standard form. You will also be finding intercepts and interpreting their meaning. A linear equation is an equation that forms a line when it's graphed. Linear equations are often written in the form ax plus by equals c. This is called the standard form of a linear equation. In this equation, c is called a constant or a number. Ax and by are variable terms. There are a couple rules, though, that you have to remember about standard form. One of them is that a has to be greater than or equal to 0. So the number in front of x has to be positive or 0. And then a and b cannot both be 0 at the same time. And a, b, and c have to be integers with the greatest common factor of 1. In the first example, y equals 4 minus 3x, we're going to determine if that is linear, and if it is, we're going to write it in standard form. So the first thing we're going to do is we're going to try to rearrange this equation so it's in the form ax plus by equals c. So we want to move this x term to the other side so it's with the y. Since it's minus 3x, we're going to add 3x to both sides. Y plus 3x, those two are not like terms, so they can't be combined together. We just leave them as two separate terms. But I'm going to write the x term first, since standard form is ax plus by equals c. And since it's a plus 3x, that's a positive 3x, so I'm going to write 3x. My y is also positive, so I'm going to write plus y equals, and on the other side we have just 4. Since I can write it in the form ax plus by equals c, it is linear. So yes, it is linear. And the standard form is 3x plus y equals 4. It fits all the rules because the number in front of x, or the coefficient of x, is greater than or equal to 0. These two numbers are not both 0. And 3, 1, and 4 do not have a common factor bigger than 1. So we are finished. In our next example, if I were to try and put this in standard form, I would have a little bit of a problem because of this right here, this minus xy. Nowhere in standard form do we have an xy term. We have an x term, a y term, and a constant. So this one right here is not linear. Why don't you go ahead and try the next two on your own? You may want to pause the video. All right, 1/3 y equals -1. I already have my constant all by itself, but over here I have 0x. I have 0x plus 1/3 y. I put 0x because there aren't any x's. 0x plus 1/3 y equals -1. This right here is not in standard form. It's not in standard form because remember that a, b, and c are integers with the greatest common factor of 1. So I need to do something to this equation so it is in standard form. I'm going to go ahead and multiply both sides by 3. If I multiply both sides by 3, three times 0x is still 0x. And I'm not going to bother to even write that in my equation. But then 3 times 1/3 y is going to be just 1y. and -1 times 3 is -3. So this one is linear because it's really 0x plus y equals -3. So that's going to be a straight line. And the standard form is just y equals -3. It's okay that c is negative. This can be negative. The only thing that can't be negative in standard form is the number in front of x. All right, in my next example, y equals x squared minus 4. I could go and move this x squared to the other side, but even if I did that, I still wouldn't have standard form because remember, standard form is just ax plus by equals c. It doesn't have an x squared in it. It's supposed to just have an x term. So this one right here is not in standard, or is not a linear equation. Basically, if you look at an equation and you see exponents, not linear. If you see an xy term, it's not linear. One thing that isn't shown in any of these examples is something like this, where you have an equation like 2x plus 4y equals 8. This is linear. It is in the form of ax plus by equals c, but it's not quite in standard form because 2, 4, and 8 all have a common factor of 2. So if you wanted to put this one in standard form, you would have to divide everything on the left by 2 and everything on the right by 2, and you would end up with 1x plus 2y equals 4. I know there are a couple problems in your classwork that are going to be like that, where once you rearrange it and have the x and y term together, you will have to take one more step to simplify it because you'll have to pull out that common factor or divide by that common factor. So a, b, and c do not have a factor bigger than 1, a common factor bigger than 1. Example 2 has to do with x and y intercepts. Basically, an x and y intercept is where it crosses the x or y axis. In this example over here, the x-intercept is where the line crosses the x-axis. In this example, the x-intercept is -4. And the y-intercept is where it crosses the y-axis. And in this example, the y-intercept is 2. The thing to remember about x-intercepts that you might want to have in your notes is that the x-intercept is when y is 0, and the y-intercept is when x is 0. Sometimes kids miss or switch those two things around and get confused. But the x-intercept is when y is 0, the y-intercept is when x is 0. So in this example, it says find the x and y-intercepts of the line graphed at the right. Well, the x-intercept is right here. The x-intercept is 20, and the y-intercept is 30. So we would choose B. X-intercept is 20, y-intercept is 30. Now in example 3, you're going to find the x and y intercepts, but then interpret what that means. It says the swimming pool is being drained at the rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. Find the x and y intercepts of the graph of the function. Well, if you look over here, the x-intercept is when y is 0. So the x-intercept is 14. Now the y-intercept is when x is 0. So the y-intercept is right there. The y-intercept is 10,080. Part B says describe what the intercepts mean in this situation. So they've drawn a little picture of the same information, or they've drawn a graph of the same information. The x-intercept of 14 means that after 14 hours, the water has a volume of 0 gallons, or after 14 hours, that's when the pool is empty. The y-intercept of 10,080, that is how much water was in the pool before it started to drain. So the x-intercept tells you how long it takes for the pool to be empty, and the y-intercept tells you what the pool was at before you started to drain it. One more for you to try on your own. It says the table shows the function relating the distance to an amusement park in miles and the time in hours the Torres family has driven. Find the x and y intercepts. Describe what the intercepts mean in this situation. Well, the x-intercept is when y is 0. So the x-intercept in this situation is 4. Basically, what that means is it takes 4 hours to get to the amusement park. Now the y-intercept is when x is 0. So the y-intercept is 248. What that means is that at 0 time, they're 248 miles away. Or in other words, they start out 248 miles from the amusement park.